Okay, so good noon everyone. Still some students are joining. So we'll wait for 1-2 minutes for them and then we'll start without wasting time. Okay, so let us start, right? So basically today the agenda of this webinar I will just discuss, right? And the agenda of this webinar is to introduce all the students, all the participants related to Chem Club and what Chem Club is, what Chem Club is doing, what we offer, what are our courses, and what are our strengths and our domain areas, right? So since this all the students are from the chemical engineering domain, so we Chem Club, we are all chemical engineers, right? So we are offering number of courses in different areas which can help the chemical engineers, right? It can be the students or they can be the working professionals to upgrade their skill levels, knowledge levels, and to switch from any one field to another field, right? So we will discuss in detail what we all offer, right? We will also discuss some of the courses, right? After that we will take a session on pumps, right? How designing is done, how working is done in the industrial level, how experts work in industry, right? So there is a gap between academics and the corporate. So how to smoothen that transition so that the students who are already in third year or fourth year can come to know about how work is being done at the industrial level. So that basically we'll be discussing. Okay, so my request will be to everyone, if you have any queries in between, you can definitely interrupt me and let me know. I will be happy to answer all your queries. Okay, if you have any questions you can definitely ask. So let us start, right? So basically our flagship program is the process engineering, right, where we discuss about different areas where process engineering will be applicable, right? So first of all we will discuss where what are the different chemical process industries and where different areas are there where we can utilize the knowledge of chemical engineering in the different areas. So first of all, we have a segment or department in an industry that is called the basic engineering department, right? So where we carry out the basic engineering of the product, right, that we want to manufacture at the industrial scale, right? So how basically it is done. So whatever product we want to manufacture as a chemical engineer, so the business development team, it comes up with an idea that if you manufacture this particular product, and this will be the profit margins and this will be the manufacturing cost, and based on that we approve the capex. So capex means आपको कोई भी प्रोडक्ट बनाना है उसके लिए आपको कुछ पैसा लगेगा. So you have to show the management that if we particularly manufacture this product, then this will be our profit, और हम 2 साल में profitable हो जाएंगे. So once that money is approved, right? So R&D team will give all the data related to the chemistry to the basic engineering team. So we will do the basic engineering. Once the basic engineering done, then comes the detail engineering part. So there will be some engineers working in the detail engineering where PNIDs will be made, equipment designing will be done, MOC selection will be done, piping will be done, everything will be done, right? One department will be utility, right? So we require different types of supporting utility, heating utility, cooling utilities to run the plant, correct? So that is a particular area where a chemical engineer works separately in the industry. One is the process safety or safety analysis, right? So nowadays uh, we are looking to the different types of industries where there are some incidents happening, right? Very catastrophic incidents. So how prior studies of the chemical processes that can be done to avoid the incidents, right? So safety studies related to that product, right? So what is the heat of decomposition, what is the heat of reaction, what is the heat of mixing, different types of heat, right? What are the layers of protection to avoid over pressurization or rise in temperature? All those analysis is done by the process safety engineer, right? So that is also one of the domain. Next one, the special case or the special role will be the equipment design. So whatever equipments, right, we are basically installing, that has to be properly designed so that it will be working as per our requirement, right? The last one is the energy management, right? So totally overall, after the commissioning of the plant, right, the main area of the focus will be energy management. Especially this will be for the refineries, right, where huge amount of energy is being consumed by the processes. So even a little bit of change you do in the process will lead to huge amount of savings in terms of energy and ultimately in terms of money, right? So that's these are the core areas of a chemical engineer in an industry, right? So why should we go for process engineering, right? So first step to kickstart your career as a process engineer or consultant, right? So currently nowadays as a chemical engineer there are basically multiple roles. Previously process engineering करके कोई team नहीं रहता था. Previously only production was the target. We were solely believing in production and earning profits. But later when the companies came up with the proper design, proper engineering standards, right, the companies who were just solely believing in the profit, making profit using production, they were outdated, right? So पहले सिर्फ प्रोडक्शन पे ध्यान देते थे, डिजाइन का कोई इतना इम्पोर्टेंस नहीं था. लेकिन विथ इंक्रीजिंग कॉम्पिटेंसी इन द मार्केट, कंपटीशन के कारण जो डिजाइन ओरिएंटेड कंपनीज थी जिन्होंने प्रॉपरली डिजाइन किया था, वो स्टिल मार्केट में सर्वाइव कर गए, right? So currently design is very important. Otherwise without any design you cannot run the plant. You can definitely get the product out of your plant, but the manufacturing cost will be very high, right? So for that reasons process engineering is the emerging branch of chemical engineering, right? So rather than production department, now majority of the industries focus on process engineering and proper design, right? So that's why it's a very good opportunity to kickstart your career as a process engineer, right? You can be a master in your domain. So whatever you have learned in the chemical engineering, your bachelor's, right, that you can definitely apply in your uh, industry, yeah, in your working professional career, right? You will have opportunities to work in MNCs and big consulting firms. So consulting firms matlab currently in refineries, right, the flow rates, the production rates are very massive, right? So in those cases generally there are not sufficient people, right, to work for the refinery. So they also hire some consultants or who are experts in designing as well as planning as well as scheduling of the products and everything, right? So day to day depending upon the crude that we are getting from the South America or Africa or from the Middle East, right? So depending upon the different types of crudes, your process parameter will keep on changing day to day, right? Temperatures, pressures of the column. So for that reason we need to have some consultants who will be doing the overall planning and consulting related to our production, right? So they will give a proper planning how your refineries will be operating based on the available crude quality, right? So that's about the consulting role. And the fourth one is you will be standing out among the others, right? So basically, if you have done something special, if you know something special, you will be definitely different from others, right? So आप बाकी सब लोगों से definitely perform अच्छा करेंगे. So that is the reason. So when I talk about myself, right, when I joined industries, right, years back, so most of the people were only focusing on the production, right, or the workplace safety, right? So us time pe, like very few people were involved in this design. So nowadays, what I did in those time is definitely helping me to develop all these skills, all this experience that I earned, right? It's definitely helping me in industry, right? So what are the different opportunities, right? So what are the different fields, what are the different companies that you can definitely target? So when we talk about consulting, it is Accenture, EY, right, KPMG. These are the big companies that basically do the consulting for the refineries. Refinery operations and designing will be ExxonMobil is there, Reliance Industries is there, right? uh, Shell is there. Similarly, EPCs. So what is EPC? Basically engineering, procurement and construction company, right? So who are basically doing the designing, construction, as well as total engineering, basic engineering plus detail engineering for the companies, right? So suppose I am the owner of the company and I want to put a plant, but I don't know any designing, right? So I will hire a EPC company. I will give them the order to set up the plant, design a plant, and they will also commission the plant for you. तो वो आपको पूरा डिजाइन करके सेटअप करके चला कर भी देंगे एंड देन यू विल बी हैविंग द हैंडओवर, आपको सौंप देंगे. ठीक है. So these are basically called the EPC companies. So Petrofec is there, Technip, Engineero. Similarly, L&T is there, Worley Parsons. These are all EPC companies. Another emerging area nowadays is specialty chemicals, right? So with the uh, huge demands of different type of chemicals, right? So day to day life mein we are using very various amount various different products which are basically chemicals, and usme bhi specialty chemicals. So it comes like pharmaceuticals hai, right? Agrochemicals hai, then solvents are there. So all this segment area is the specialty chemicals. So when we talk about the breakup, right? So entire industry, there are three, basically three domains. One is the petroleum and refinery section, one is the EPC or you can say consultancy section, and third one is the chemical section, right? So you can choose which area you are interested in and where you can perform your best, right? So when we talk about process engineering, right, so what you will be learning, so we will take care of what is basic engineering. So we will let you know how basic engineering is done, how designing is done. So basically designing of distillation column, exchangers, pumps, right? Design basis, how to prepare a design basis, heat and mass balance, right? PFDs, PDS, PNIDs, IPDS, right? So HMBs, heat and mass balance, PFDs, process flow diagrams, process data sheets, PNIDs, instrument process data sheet. So whatever documents are required, right, related to the design, how to prepare those documents, how to select the equipments, that basically we will be focusing on in our all the courses, right? Any doubts, anyone? Yes, कोई क्वेरी है किसी को? Okay. So the main program basically that will be helpful for the college students, it is basically the process engineering, right? Process engineering course. It is called the PDEC course, so process design and engineering course. So we will give you overview like what all topics are covered. So basically we'll give you the overview of the industries, what is the role of a process engineer. So that should be very clear that what is the role of a process engineer, right? Next one is the process design basis, PNIDs, IPDS, heat and material balance, preparation of PDS, that is data sheet of different types of equipments. So data sheet मतलब क्या होता है, कोई भी equipment का कुंडली, right? So वो data sheet में उस equipment के बारे में सारी details होती है. So that is called basically the data sheet of the equipment, right? So when we talk about the pump, तो उसका flow rate कितना है, उसका pressure कितना है, what is the material of construction, what is the RPM, motor का capacity कितना है, उसका इनलेट आउटलेट, राइट, impeller diameter, everything related to the pump will be covered in the PDS. So how to prepare that PDS, आपने साइजिंग किया, you came up with some value, right, जो भी आपका कैलकुलेशन था, फिर उसको आपको PDS में डालना पड़ेगा. So that is basically how to prepare the PDS. So format is mostly same for all the industries, right? Whatever data are there that are common for the pump, सारे इंडस्ट्रीज में सेम ही रहता है. तो हाउ टू प्रिपेयर दोस पीडीएस फॉर डिफरेंट टाइप्स ऑफ इक्विपमेंट्स, राइट, दैट विल बी बेसिकली इंक्लूडिंग. Then line sizing, control valve sizing, pump sizing and calculations, heat exchanger sizing, safety devices, right? So PSV है, pressure safety valve is there, PRV is there, pressure relieving valve, right? Cooling water sizing, so how to size a cooling water, and utilities, right? So what all features are related to the course that we are displaying? So first of all you will be having the live lectures, right? So पूरा जो कोर्स है उसके जितने भी टॉपिक्स है उसका हम डिटेल टाइम टेबल देते हैं बेस्ड ऑन द डेट एज वेल एज टाइमिंग, एंड जो भी लेक्चर लेंगे, राइट, उनका नाम रहेगा, ट्यूटर का नाम, राइट. So we will strictly follow the schedule. As per the schedule we will share the link on Microsoft Teams and we can join the live lecture, right? If some student is not able to attend the live lecture, then you can also have the recorded lectures. We will separately have a doubt clearing session if any student has any doubts, right? There will be weekly test, right? Full time assistance will be there. So at any time anyone have any query, then you can directly contact the tutor, or you can post your query on the WhatsApp group also. Certification guidance, right? So basically there are also some courses where certification is required, right? So we also provide courses on HTRI, SPEN, right, SPEN HISIS. So there we will also help you to get the certification, right? So uska ek exam bhi rehta hai, so we will also guide you through that certification, right? And through our community we will help all the students, right, to know about the industries. We will help them to make contacts so that they can also get to know about the other people, other students who all are working in this industry, right? So basically through this we are building a community, right? So this is about the course, right? So basically now we are offering especially for the students, this is the price for the process design and engineering course, right? So based on the flexibility we can adjust. Mostly the course sessions are happening in the evening, right? Mostly शाम को रहता है, somewhere around 7 to 9 के बीच में, right? So whoever, mostly it can be a student or it can be a working professional, right? So who are working from morning 9 to 5, so that they can easily attend in the evening, right? So we also have some flexible timing. If students are there, right, multiple students are not available, then we can shift the timing and we have that flexibility, right? So basically how you can register, so this is our website, www.camclub.com. You can go to the course section, so whatever course you want you can add that course, right, make the payment and you are ready to go, right? So if you have a query, then our backend team will be there to help you, right? So what all different courses will be basically providing is Aspen Plus, Aspen HYSYS, Aspen EDR is there, Process Design Engineering. So this course is the basically the well-known course where we'll be covering the entire designing part. Distillation, we also have a very short course on distillation, right? PSV sizing. So related to the Aspen Plus, the course duration is 24 hours. Mostly it's evening batch, right? Similar for HYSYS, it is again the same. It's a 24 hours course. So mostly 24 hours, and suppose every day 1 hour session will be there, right? So mostly this course will take place in 1 month. So these two, both the course Aspen Plus and HYSYS, they are both 1 month course. Aspen EDR is again somewhere around 1 month, less than a month course. Process Design Engineering is a 2 month course, detail engineering, right? So that I will just let you know how this Process Design Engineering course is. Distillation, this is a 10-day course where everything related to the distillation A to Z, right from the your core principles and your uh, principles of distillation से लेके उसका डिजाइन, राइट, उसका ट्रबल शूटिंग, उसका सिलेक्शन, इंटरनल साइजिंग, एवरीथिंग रिलेटेड टू द डिस्टिलेशन, totally the design related to the distillation column that we are covering. So this is a short 10 days course. Aspen, Flarenet and PSV sizing. So related to the process safety, it is also again a 1 month course. So this is the range of our courses that we are providing, correct? Okay, so that's it. So this is basically about the Chem Club. So anyone have any queries related to the courses or any questions till now? Anyone, any student want to ask anything? Yes, कोई डाउट है किसी को? Okay. So let us discuss on a topic, right? So we will discuss about the pumps, right? Then I will take you through the entire process design engineering course, right? उसका हम ओवरव्यू दे देंगे आपको. So can anyone tell me, like, जो भी स्टूडेंट्स है वो कौन से सेमेस्टर से है? right? So it will be like if I know, then मुझे भी पता चलेगा up to what depth I need to go, right? सारे स्टूडेंट्स फोर्थ ईयर वाले हैं?
Yes.
Sir, third year.
Okay, okay. And these all students are from GC Bhuj, right?
Yes, sir.
Okay.
Yes, sir.
Okay, so let us discuss about the pumps, right? So we will have, this is basically how we will be providing the material, right? So before the course, right, we will provide this material to the students, right? So they can have that with them for the lifetime. We also have the lifetime access to the recorded session. तो आप कभी भी जाके सेशन देख सकते हो, right? So कोई बता सकता है on what principle the pump operates, right? Pump कैसे काम करता है? Can anyone tell me? How does a pump operate? कौन से प्रिंसिपल पे काम करता है? Yes, anyone? कोई बता सकता है? Yes, anyone?
Sir, basic force nature to gases liquid.
Sorry, can you please repeat?
Sir, basic force पे operate करता है.
Okay,
Sir, centrifugal force पे.
okay. So that is correct. So as we say pumps, so basically there are two types of pump. First of all, right? So one is a reciprocating pump, and the second one is a centrifugal pumps, right? So reciprocating pumps रहते हैं, there are like a piston or a cylinder or gears are there. So basically वो जो भी fluid है उसको displace करते हैं. So that principle is simple. Another one is the centrifugal pump. So how does a centrifugal pump operates? So basically we provide some electric energy, that is electricity. So we provide some power to the motor. That power, electrical energy, is converted into rotational energy through a motor. That pump, that motor shaft is connected with the pump shaft through a coupling, right? So that pump will start rotating, and based on the rotation, that rotational energy will get converted into kinetic energy of the pump, right? तो बेसिकली पंप कैसे काम करता है, तो उसका आप सिंपल एग्जांपल जस्ट मैं आपको समझाऊं, राइट? सो सपोज एक प्लेट है, राइट? आप जो खाना खाते हैं वो एक प्लेट है, राइट? और उसके अंदर आप थोड़े कुछ गोलियां डाल देंगे, राइट? सो स्मॉल स्मॉल बॉल्स इफ यू ऐड, राइट? सो इफ दैट प्लेट इज स्टैग्नेंट, तो क्या होंगे? बॉल्स भी स्टैग्नेंट होंगे. अगर आपका प्लेट मूव नहीं होगा तो बॉल्स भी मूव नहीं होंगे. अगर आप प्लेट को सेंटर सेंटर से आप मूव करना स्टार्ट करें, इफ यू प्रोवाइड द रोटेशनल एनर्जी, देन व्हाट विल हैपन? जो भी सारे आपके बॉल्स या जो भी छोटे बॉल्स आपने अंदर प्लेट में डाले थे, वो कहाँ चले जाएंगे? इट विल गो ऑन द बाउंड्री, इट विल गो ऑन द पेरिफेरी ऑफ दैट प्लेट, right? So what happens? Because of the rotational energy, right, that rotational energy of the plate is pushing the marbles or the small balls towards the periphery, right? So that is basically the rotational energy of the shaft, right? It is as a centrifugal force is being converted into kinetic energy of the fluid, right? So rotational energy जो आप दे रहे हो प्लेट को, वो क्या हो रहा है? छोटे छोटे मार्बल्स को पुश कर रहा है और उनकी काइनेटिक एनर्जी बढ़ रही है, राइट? पहले जो मूवमेंट नहीं कर रहे थे, नाउ दे आर मूविंग. सो दैट इज द प्रिंसिपल ऑफ द पंप, राइट? सो द प्रिंसिपल ऑफ द पंप सेज right? The principle of the pump is when the water or any fluid enters the eye of the impeller and exits the impeller with the help of a centrifugal force, right? So it basically boosts the kinetic energy, right? And ultimately it develops the pressure, right? So that is how basically a pump will operate. So what are the different parts of the pump, right? So when we see a pump, there is one suction, one discharge, there is the impeller, which is the main part of the pump, right? On which this pump will be operating, right? So what is the impeller? So impeller अंदर एक basically there is a assembly, right? Basically जो rotor के साथ connected रहता है, and जब rotor घूमता है, that impeller is designed in such a way that it will direct the fluids towards the periphery and ultimately discharge it out of the pump, right? So pump basically कोई भी fluid का velocity बढ़ाता है and ultimately it develops the pressure. So now can anyone tell me which law will be applicable to the pump? हम कॉलेज में पढ़ते हैं, so which law is applicable to the pump? कौन सा इक्वेशन फॉलो करेगा पंप? यस, फ्लूइड मैकेनिक्स में आपने पढ़ा होगा. कोई बता सकता है? एनीवन?
Velocity increase, pressure decrease.
Yes. Which law is applicable?
Sir, FMT laws.
यस, आपका आवाज क्लियर नहीं आ रहा है.
Continuity equation.
Yes, so that is basically the
Sir,
Bernoulli's
FMT law.
equation. Bernoulli's equation will be applicable, right? So what are the three components? It is the pressure, it is the height, and the velocity head. So pressure head, static pressure head, as well as the velocity head, right? So जब भी आपका पंप का डिस्चार्ज वाल्व, राइट, पंप का आउटलेट में जो वाल्व होगा इधर वो क्लोज होगा, तो क्या होगा? आपका प्रेशर मैक्सिमम होगा, राइट? लेकिन वेलोसिटी कुछ भी नहीं है. जैसे ही आप वाल्व ओपन करेंगे तो क्या होगा? आपका वेलोसिटी बढ़ जाएगा, लेकिन आपका प्रेशर कम हो जाएगा, राइट? सो जब आप, सिंपल एग्जांपल, जब आप गार्डन में पानी पिलाते हैं जो भी पेड़ पौधे हैं, राइट, एट दैट टाइम आपके हाथ में एक पाइपलाइन है, राइट? सो आप क्या करते हो? अगर आपको दूर तक पानी पहुंचाना है, सो यू रिड्यूस द एरिया, करेक्ट? सो यू आर प्रोवाइडिंग सम रेस्ट्रिक्शन, correct? So whenever you are providing the restriction, what happens? You are creating some pressure drop, right? So your pressure will be lesser at that point, but that reduction in the pressure is resulting into increasing in velocity. So as per the Bernoulli's equation, the pressure head, the static pressure head, and the velocity head is always constant. या तो आपका प्रेशर हो गया मतलब आपका वेलोसिटी बढ़ेगा, राइट? सो जब आप वेलोसिटी बढ़ाते हो कोई भी फ्लूइड की, व्हाट डज इट मीन? आप उसका हेड या प्रेशर कम कर रहे हो, करेक्ट? सो दैट इज द प्रिंसिपल ऑफ द पंप, राइट? सो वी विल क्विकली डिस्कस व्हाट आर द डिफरेंट पंप कर्व्स, राइट? आपने कॉलेज में पढ़ा है पंप कर्व्स के बारे में, हाउ द पंप ऑपरेट्स, व्हाट आर द पंप कर्व्स? यस और नो? पंप कर्व्स के बारे में पढ़ा है सबने?
No, sir.
ओके, तो पंप कर्व्स मतलब क्या रहता है? सो व्हेनेवर यू आर ऑपरेटिंग अ पंप, राइट? सो जैसे कि आप कभी भी कुछ भी चीज आपको परचेज करना है, तो आप, फॉर एग्जांपल, यू आर गोइंग एंड बाइंग अ प्रोडक्ट फ्रॉम द मार्केट, तो आप क्या देखते हैं? उसका एक्सपायरी डेट, उसके इंग्रेडिएंट्स, राइट, कौन सा कंपनी है, कैसा टेस्ट है, राइट? So whenever you are buying a pump, so before buying the pump, the vendor will supply you with the pump curves, right? So वो pump curves में आपको शो करेंगे कि अगर हमारा पंप चलेगा तो how it will be operating, right? So that basically is pump curve. So when we talk about the pump, this is the most, right, highly important topic related to the pumps. So just my advice is be thorough with the pump curves, because you will definitely 100% you will face these questions in your future upcoming interviews or your campus recruitments, right? So this is a very important topic. So when we talk about the pump curve, right, on the x-axis always there is a flow rate, right? So that is the flow rate of the pump. अगर अगर समझ में नहीं आया, any doubt है, then you can definitely ask in between, correct? So with respect to the flow rate, how my different parameters will be varying of that particular pump, that basically the pump curve will be showing, right? So when it is the head, that is the pressure developed by the pump, right? So जब भी आपका flow rate zero है, on x axis it is zero, right? So यहाँ पे जब zero है तब आपका head maximum है, right? So because your shut off valve, your discharge valve is closed, right? तो जब भी आपका पूरा पंप का आउटलेट वाल्व क्लोज है तब क्या होगा, फ्लो रेट जीरो होगा और उसका प्रेशर मैक्सिमम होगा, राइट? जैसे आप वाल्व खोलोगे तो क्या होगा, आपका फ्लूइड मूवमेंट शुरू हो जाएगा, राइट? सो योर फ्लूइड इज गेटिंग सम वेलोसिटी. सो एज द वेलोसिटी इंक्रीजेस योर प्रेशर स्टार्ट्स ड्रॉपिंग, बिकॉज बर्नौलीज इक्वेशन क्या बोलता है, वेलोसिटी हेड मतलब क्या है, v square by 2g, right? So your velocity starts increasing, so your pressure will start decreasing, because p plus gz plus v square by 2g is always constant as per Bernoulli's equation, correct? So your pressure is started to drop, right? So that is basically the head and flow rate curve, correct? Similarly, the efficiency of the pump, right? So what is the efficiency of the pump? It is basically the output that is provided by the pump divided by the input that we are providing. So what is the input? That is the electrical energy, correct? And what is the output? That is the flow rate with some pressure. तो जब भी आपका फ्लो रेट जीरो है तो आपका फ्लूइड का मूवमेंट ही नहीं है कुछ, राइट? लेकिन हम पंप को एनर्जी दे रहे हैं. जब आपका पंप स्टार्ट किया है लेकिन उसका फ्लो रेट जीरो है, आपने वाल्व बंद करके रखा है लेकिन पंप, राइट, इट इज जस्ट रोटेटिंग, वो पावर दे रहे हैं उसको, लेकिन पंप का वाल्व हमने ओपन नहीं किया तो फ्लो रेट हमारा जीरो है, तो क्या होगा, योर एफिशिएंसी विल बी जीरो. जैसे ही उसका वाल्व यू विल स्टार्ट ओपनिंग, योर फ्लो रेट विल बी इंक्रीजिंग, right? So your efficiency will go and increase to a peak and it will start decreasing, right? So why this decreases, efficiency decreases after certain time, is because at very high flow rates, right, as your flow rate increases, your Reynolds number starts to increase, and at higher Reynolds number your frictional loss starts increasing, right? Reynolds number मतलब क्या है, rho v d by mu, राइट? आपका v यानी कि वेलोसिटी बढ़ जाएगा ना, आप जैसे उसका फ्लो रेट बढ़ेगा, आपका एरिया भी सेम है पाइप का, सो योर वेलोसिटी विल इंक्रीज, योर रेनॉल्ड्स नंबर विल इंक्रीज, एंड अल्टीमेटली योर फ्रिक्शन फैक्टर विल इंक्रीज एंड योर फ्रिक्शनल प्रेशर ड्रॉप विल इंक्रीज. So that's why the efficiency drops at the end. Up to certain point it will increase, but after a point it will decrease, right? समझ में आया सबको? Yes or no? Yes? Any queries? समझ में आ रहा है सबको? Okay. Similarly, when we talk about the power, right? So even when your flow rate is zero, your pump is not delivering any flow rate, right? But still it will consume some power. आपने पंप को स्टार्ट किया लेकिन उसका वाल्व ओपन नहीं किया, so still it is consuming some power. So as soon as the flow rate start increasing, it will start to consume the power. So power will keep on increasing with flow rate. अब जितना flow rate बढ़ाते जाओगे उतना power आपका increase होता जाएगा, right? So that is a straightforward relationship. Similarly, the NPSH requirement, right? So at lower flow rate, your NPSH requirement is lesser. So when your flow rate increases, your NPSH requirement increases, right? Can you tell me what is NPSH? Yes, any student कोई बता सकता है what is basically NPSH of a pump? Full form क्या है?
Net positive suction head.
Correct, exactly correct, very good. So net positive suction head. So इसका importance क्या है, आप बता सकते हो? Why is it important? What does that signify?
Priming and cavitation.
करेक्ट. अभी आपने आंसर दिया है तो मेरा फॉलोअप क्वेश्चन रहेगा, व्हाट इज बेसिकली कैविटेशन देन? कैविटेशन मतलब क्या है?
Vapor pressure is greater than greater बोल दे.
ओके. सो कोई एक बता सकते हो? आप दोनों ने आंसर दिया तो मुझे किसी का सुना ही नहीं दिया. यस.
जब सक्शन प्रेशर लो होता है तब वो वेपर होता है, वो बबल में लिक्विड का वेपर में कन्वर्ट हो जाता है, वो वेपर बबल्स में क्रिएट होता है. फिर थोड़े टाइम के बाद वो अगेन प्रेशर रिड्यूस होता है और वो बबल्स क्रिएट होता है और कोलैप्स होकर वो शाफ्ट को डैमेज करते हैं.
ओके. सो ऐसा क्यों होता है? उसका कोई रीजन है, पर्टिकुलर रीजन व्हाई कैविटेशन हैपेंस? और अगर कैविटेशन अवॉइड करना है तो मुझे क्या करना चाहिए? हाउ कैन आई अवॉइड कैविटेशन देन?
Priming.
सो आप ऐसा बोल सकते हो, अगर आपने प्राइमिंग एक बार कर दिया तो वो कैविटेशन होगा ही नहीं फिर?
Suction pressure always greater than vapor head.
वेपर हेड या सक्शन प्रेशर शुड बी ऑलवेज ग्रेटर देन द एनपीएसएच रिक्वायर्ड?
Yes, sir. Same.
सो बेसिकली क्या रहता है, आपको हमेशा पंप के सक्शन में कुछ पर्टिकुलर प्रेशर मेंटेन करना है, राइट? सो जब वेपर प्रेशर की बात आती है तो क्या होता है? वेपर प्रेशर मतलब क्या है? द प्रेशर ऑफ द वेपर ऑफ एनी लिक्विड, करेक्ट? सो जैसे कि लो वेपर प्रेशर, हाई वेपर प्रेशर वाले लिक्विड्स है, सपोज पेट्रोलियम इज देयर, राइट? तो आप पेट्रोल पंप पे पेट्रोल भी भरवाते हो तो भी उसकी वेपर्स आपको दिखती है एट नॉर्मल टेम्परेचर, राइट? सो उसका वेपर प्रेशर हाई है, इट गेट्स इजीली इवोपरेटेड, उसका बॉइलिंग पॉइंट लो है. लेकिन कुछ ऑयल्स है, हेवी ऑयल्स है, जिनका बॉइलिंग पॉइंट 400 डिग्री सेंटीग्रेड है, राइट? सो दीज ऑयल्स हैव वेरी लो वेपर प्रेशर. सो जब भी आप पेट्रोलियम, राइट, जिसका वेपर प्रेशर बहुत ज्यादा है, उसको आप पंप करेंगे तो क्या होगा? पंप कैसे ऑपरेट करता है? पंप के सक्शन में कुछ सक्शन क्रिएट होता है बिकॉज ऑफ द रोटेशन ऑफ द पंप. तो सक्शन क्रिएट होता है तो क्या होता है? इट विल क्रिएट अ लिटिल बिट ऑफ वैक्यूम. वो फ्लूइड को खींचने के लिए जब रोटेट होगा इंपेलर तो इट विल क्रिएट अ बिट ऑफ वैक्यूम. सो आपका प्रेशर जैसे कम होता है, राइट? व्हाट इज द रिलेशन बिटवीन द बॉइलिंग पॉइंट? सपोज आपका वाटर है, राइट? सो वाटर का बॉइलिंग पॉइंट कितना है?
100
100.
degrees.
राइट, करेक्ट. सो
100
अगर मैं
degree.
वाटर का बॉइलिंग पॉइंट मेरा 100 डिग्री सेंटीग्रेड है एट एटमॉस्फेरिक प्रेशर, अगर मैं प्रेशर को 2 एटमॉस्फेयर कर दूंगा तो मेरा बॉइलिंग पॉइंट सेम होगा या चेंज हो जाएगा?
Change हो जाएगा.
सो इट विल इंक्रीज मोर देन 100 होगा या लेस देन 100 होगा?
More than 100.
करेक्ट. सो जब आप प्रेशर बढ़ाते हो तो क्या होता है? उसका बॉइलिंग पॉइंट बढ़ जाता है. और सिमिलरली अगर आप प्रेशर कम कर देते हो तो उसका बॉइलिंग पॉइंट कम हो जाता है, राइट? सो व्हाट हैपेंस व्हेन यू आर पंपिंग सम volatile fluids या high vapor pressure fluids like petroleum, kerosene, right, benzene, toluene. So उस केस में when your pump is creating some suction, so because there is some suction, there is little bit of vacuum, and because of that reduced pressure in the pump suction, आपका प्रेशर जैसे कम होता है, उसका बॉइलिंग पॉइंट कम हो जाता है, उसका वेपर प्रेशर बढ़ जाता है. तो देर इज वेरी हाई पॉसिबिलिटी कि वो जो आपका लिक्विड है, टैंक के अंदर लिक्विड होगा, राइट? लोग बोलेंगे कि वो कैसे कन्वर्ट होता है वेपर में, टैंक में तो लिक्विड है, लेकिन वो पंप के सक्शन में इट गेट्स कन्वर्टेड इनटू वेपर. दैट वेपर विल गो एंड स्ट्राइक ऑन द इम्पेलर जो घूम रहा है, and at very high velocity that impeller is rotating at a very high rpm, it is rotating. और उसमें अगर वेपर बबल्स और कैविटीज उसको स्ट्राइक करेंगे सो इट विल स्टार्ट मेकिंग एबनॉर्मल नॉइस, राइट? तो दैट एबनॉर्मल नॉइस इज बेसिकली कैविटेशन. तो उसे अवॉइड करने के लिए हमें क्या करना है? सो पंप का ऑपरेशन के लिए, राइट, देयर इज सम एनपीएसएच रिक्वायर्ड दैट इज प्रोवाइडेड बाय द वेंडर, राइट? काफी बार हम क्या बोलते हैं कि ये पंप का एनपीएसएच रिक्वायर्ड 5 मीटर्स है. तो 5 मीटर्स head is the NPSH और 0.5 kg is the NPSH. So हमेशा हमें पंप के सक्शन में उससे ज्यादा प्रेशर मेंटेन करना है. हेलो, यस बोलिए. ओके, सो अगर हम NPSH रिक्वायर्ड जो प्रेशर है जो वेंडर ने दिया है उससे ज्यादा प्रेशर अगर हम मेंटेन करेंगे तो क्या होगा, आपका प्रेशर हमेशा ज्यादा होगा. अब आप कैविटेशन को कैसे अवॉइड कर सकते हैं, या तो आप उसका प्रेशर बढ़ा दो जिसके कारण वो वेपराइज ना हो, उसका बॉइलिंग पॉइंट बढ़ जाए, या तो उसका टेम्परेचर कम कर दो. राइट, अगर 100 डिग्री का पानी 90 डिग्री वाला अगर आप पानी पंप करेंगे तो कैविटेशन हो सकता है, लेकिन अगर आप 25 डिग्री वाला पानी पंप करेंगे तो कैविटेशन नहीं होगा, बिकॉज देर इज अ ह्यूज अमाउंट ऑफ डेल्टा, देर इज सम टेम्परेचर ग्रेडियंट बिटवीन द बॉइलिंग पॉइंट एंड द करंट टेम्परेचर ऑफ द फ्लूइड. राइट, और आप क्या कर सकते हो, उसका सक्शन प्रेशर बढ़ाने के लिए उसका टैंक का हाइट बढ़ा दो. राइट, आपका पंप ग्राउंड फ्लोर पे रखो और टैंक को फोर्थ फ्लोर पे डाल दो. सो बिकॉज ऑफ द हाइट ऑफ द स्टैटिक हेड आपका फ्लूइड का प्रेशर बहुत ज्यादा होगा जिसके कारण वो बॉयल ऑफ नहीं होगा या वेपराइज नहीं होगा. सो दिस इज हाउ यू कैन बेसिकली अवॉइड द कैविटेशन. क्लियर है, समझ में आया सबको? यस और नो?
Yes, sir.
Yes, sir.
Yes.
So these type of questions, still in detail, there are very huge number of possibilities you can design, right? So from your level, like this is how basically we can avoid the cavitation, right? So your NPSH requirement, you can see आपका NPSH requirement मतलब क्या, उतना मिनिमम प्रेशर जो हमें पंप के सक्शन में रखना है जिसके कारण कैविटेशन ना हो, उसे हम बोलते हैं NPSH required. That is provided by the vendor. तो वेंडर बोलेगा कि अगर आपको पंप को कैविटेशन से बचाना है तो आपको पंप के सक्शन में इतना प्रेशर रखना ही है. सो व्हाट शुड बी आवर NPSH अवेलेबल. अवेलेबल मतलब हमारे सिस्टम में कितना है, तो हमारे सिस्टम में हमेशा NPSH रिक्वायर्ड जो वेंडर ने जो बताया है उससे ज्यादा होना चाहिए. सो ऑलवेज यू रिमेंबर NPSH अवेलेबल should be always greater than NPSH required to avoid cavitation. सो किसी स्टूडेंट्स ने मुझे पूछा कि आपका NPSH रिक्वायर्ड जो है वो तो आप वेंडर देता है हमें, राइट, इट शुड बी फिक्स्ड, लेकिन वो फ्लोरेट के साथ बढ़ क्यों रहा है? तो कोई बता सकता है व्हाई इट इज इंक्रीजिंग विथ रिस्पेक्ट टू फ्लोरेट? बिकॉज आपका फ्लोरेट जब
Losses.
बढ़ता है, यस बोलिए.
सर फ्लो रेट इंक्रीज होगा तो लॉसेस होंगे, हेड लॉसेस, फ्रिक्शनल लॉसेस.
करेक्ट. सो जैसे फ्लोरेट इंक्रीज होगा योर रेनॉल्ड्स नंबर विल इंक्रीज, योर फ्रिक्शनल लॉसेस विल इंक्रीज, तो उसके कारण क्या होगा, प्रेशर ड्रॉप होगा. करेक्ट. तो आपका जो सक्शन में आप प्रेशर मेंटेन कर रहे थे, राइट, NPSH अवेलेबल जो भी आप मेंटेन कर रहे थे उससे थोड़ा कम मेंटेन होगा, राइट. सो योर NPSH इज रिक्वायर्ड, दैट्स व्हाई इट इंक्रीजेस. जैसे आपका पंप में सक्शन, आपका फ्लो रेट बढ़ेगा, लॉसेस भी बढ़ जाएंगे. टू अवॉइड दैट लॉसेस, राइट, टू टेक केयर ऑफ द लॉसेस, तो आपको NPSH रिक्वायरमेंट भी बढ़ाना पड़ेगा, राइट. तो बिकॉज दिस लॉसेस आर इंक्रीजिंग वी हैव टू इंक्रीज द NPSH. तो आपका अवेलेबल NPSH जो था ना उसका कुछ पार्ट लॉसेस को ओवरकम करने में जा रहा है, इसलिए आपको NPSH रिक्वायर्ड बढ़ाना पड़ रहा है. करेक्ट. तो आपने काफी बार इंडस्ट्रीज में देखा होगा, एज पर गुड डिजाइन आपका पंप और आपके जो टैंक है जहां से आपको पंप आउट करना है वो दोनों एकदम पास में होने चाहिए, राइट. एंड योर सक्शन लाइन शुड हैव मिनिमम बेंड्स, राइट. तो उसमें बेंड्स, कर्व्स मिनिमम होने चाहिए, लाइन फिटिंग्स, एवरीथिंग शुड बी मिनिमम. क्योंकि अगर आपने सक्शन टैंक और पंप के सक्शन को दूर दूर रखा, राइट, एक जगह पे टैंक है और दूसरी जगह पे 200 मीटर दूर अगर पंप है, right, so in that case your pump will definitely cavitate. So always you will find the tank and the pump both are very near to each other, so that is the reason. Clear?
Clear.
Okay. So we have the equations for the power that is generated. So how the basically the power you will be calculating, right? So power में भी कैसा रहेगा, right? So when we talk about the power, ऐसा क्यों हो रहा है, right? So आपका first of all you are giving some power from the to the motor. To the motor that power is going to the pump, and from the pump that power is going to the fluid, right? तो आपका जो पावर, हाइड्रोलिक पावर मतलब क्या हुआ, आपको जो वर्क डन मिला बाय द पंप, राइट? सो वर्क डन बाय द पंप इज बेसिकली रिलेटेड टू हेड फ्लो रेट ऑफ द पंप. तो आपने कितना वर्क डिलीवर किया, पंप ने कितना वर्क डिलीवर किया, वो डिवाइडेड बाय पंप को कितना पावर मिला, राइट? सो वर्क डन बाय द पंप डिवाइडेड बाय द पावर सप्लाइड टू द पंप, दैट इज बेसिकली कॉल्ड द पंप एफिशिएंसी, राइट? तो ऐसा भी हो सकता है कि पंप को जितना पावर दिया तो उसमें से पंप ने कुछ वर्क किया, द वर्क डन बाय द पंप, और पंप ने कुछ लॉसेस दिए. सो लॉसेस रिलेटेड टू द फ्रिक्शन, लॉसेस बिकॉज ऑफ कैविटेशन. आपका पंप कभी आप गर्म हो जाएगा, राइट? सो पंप इज एमिटिंग, it is dissipating some energy in terms of heat, in terms of frictional losses, right? In terms of heating of the sealing system, heating of the shaft, right? So that is basically the losses from the pump. So उसका efficiency कम हो जाएगा, right? So that is related to the pump efficiency. Similarly motor will also have some efficiency. जब आप मोटर को suppose generally कैसा रहता है, suppose you are supplying 100 kilowatt of energy to the motor, then motor will give 85 kilowatt of energy to the pump. 85 kilowatt pump का input हुआ, जिसमें से आपको effective 65 kilowatt of work done you will get. So आप देख सकते हो कि 100 kilowatt I am supplying और मुझे सिर्फ end में 65 मिल रहा है या 60 मिल रहा है. So there is a drastic consumption of energy because of losses, right? So आपका मोटर में लॉसेस क्यों होता है, राइट? कोई बता सकता है व्हाई देयर इज लॉसेस इन मोटर? और जनरली यू विल बी शॉक्ड टू सी कि अगर मोटर में हम 100 किलोवाट पावर देते हैं, देन मोटर गिव्स जनरली 80 किलोवाट ऑफ आउटपुट. सो 20 किलोवाट, सो approximately 20% losses happens in the motor. So why that losses happen?
loss.
मोटर लाइक यू आर सप्लाइंग पावर टू द मोटर, और मोटर का शाफ्ट से आप पंप के शाफ्ट को दे रहे हो, राइट? सो मोटर में तो कोई फ्लूइड मूवमेंट ही नहीं है ना. सपोज इवन योर मोटर इज नॉट कनेक्टेड विद द पंप शाफ्ट, अकेला मोटर भी आप घुमाओगे, स्टिल इट विल हैव ह्यूज अमाउंट ऑफ लॉसेस. व्हाई दैट लॉसेस आर हैपनिंग? मोटर के ऊपर फिन्स देखे आपने, जिगजैग पोजीशन में फिन्स रहते हैं. व्हाई दोस फिन्स आर गिवन?
Yes, sir.
Because when your motor is rotating at the high rpm, right, that is the induction motor working on the Faraday's law. So because of induction your coils get heated up, right? आपका फैन जो नॉर्मल घर में फैन है वो तो छोटा कॉइल रहता है, दैट इज सिंगल कॉइल फैन, राइट? और उसका वोल्टेज भी कम रहता है. बट इंडस्ट्रियल मोटर्स दे आर 440 या 3.6 kV और 6.6 kV की मोटर्स रहती है, राइट? एंड 3 पोल मोटर्स, यानी कि उसमें 3 अलग अलग वाइंडिंग रहते हैं. सो व्हेन इट रोटेट्स एट द हाई आरपीएम, these coils get heated up, right? So ultimately your motor will get heated up. So in order to dissipate that energy, right, आपके heat losses बहुत ज्यादा होते हैं इंडस्ट्रियल मोटर्स में, right? नॉर्मली इवन योर फैन, अगर वो आप फैन चालू है 1-2 घंटे और उसको आप टच करेंगे, सो इट विल बी वेरी हॉट, राइट? जबकि उसका फंक्शन और उसके आरपीएम तो काफी कम है व्हेन वी कंपेयर टू इंडस्ट्री, राइट? सो इंडस्ट्रियल मोटर्स, राइट, these all motors give generally efficiency of 80 to 85% because heat losses are very very high, because your there are 3 different windings in the same motor, right? So because of that reason your efficiency is lost. Now when your motor shaft is coupled with the pump shaft, right? There are again some coupling losses. अगर आपका alignment सही नहीं है, right? If your motor का shaft और pump का shaft सही तरीके से connect नहीं किया, there will be some mismatch in the alignment. So that will result into little bit of offset and frictional losses there also, right? Vibration losses will be there, noise losses will be there. So because of that also some of your efficiency will be reduced. Clear? Okay. So basically hydraulic power is the flow rate multiplied by the total head developed by the pump multiplied by the density, the gravitational constant divided by the 1000, right? So what is the pump shaft power, right? So basically यहाँ पे हम या तो हम pump shaft power, what we do in industry, either you calculate the efficiency or you calculate the input to the pump shaft. So generally what we do is efficiency of the pump is equal to hydraulic power or the work done by the pump divided by the power provided to the shaft, right? So हम क्या करते हैं, we assume the efficiency. Suppose हमारा pump 70% efficiency से काम करेगा, तो हमें उसको कितना shaft कितना power देना है. So suppose I have some flow rate, some head I have decided. So I want my pump to do some hydraulic work. So that is the hydraulic power divided by 0.7, because my assumption is I want to operate my pump at 70% efficiency. तो मुझे पता चलेगा कि पंप के शाफ्ट को कितना पावर देना है. So once that power is calculated, what is my electrical input power? The pump shaft power divided by the efficiency of the motor. Now efficiency of the motor is 80%, so that is 0.8. So whatever that power will come, right? So this power is the power input to the motor. तो मुझे मोटर को इतना पर्टिकुलरली पावर देना है जिसके कारण मेरा 80% तो मोटर में लॉस होगा, 70% पंप में लॉस होगा, and then I will give my desired hydraulic power or my pump will give me desired work done. Correct? So this is how basically we will do the sizing and power load calculations for the pump, right? During our live session or during the classes, हम स्टूडेंट्स को रिक्वेस्ट करते हैं कि आप साथ साथ पैरेलली वी विल आल्सो डू अ एंटायर साइजिंग ऑफ द पंप यूजिंग द एग्जांपल इन द एक्सेल शीट, राइट? सो दैट विल बी हेल्पफुल, राइट? जस्ट अ मिनट, मैं आपको अवेलेबल रहेगा तो एक एक्सेल शीट डिजाइन के लिए मैं आपको शेयर करता हूँ. अभी तक किसी को कुछ डाउट related
Everyone
to
is
pump?
able to see the feedback form. Please let me know.
Yes, sir.
Okay. Kindly fill this form. Okay. Sir, you can go ahead.
Okay, okay. अभी तक कुछ क्वेरीज है किसी को? Any doubts you have? Anyone related to the pumps? Yeah, any other topic related to your bachelor's? If you have any queries, you can ask. Yes, anything? Okay.
Everyone, please, if you have any ask, you can ask the trainer.
Is any doubt related, like pump ke related, या any other technical queries or anything you want to ask, you can definitely ask.
William, sir, you are available?
Yes, sir. Good afternoon. I am there, sir.
Sure, sir. On behalf of the students, you can ask anything if you have any queries.
Yeah, basically,
let us wait for 1 minute or so. If any students have to ask something, so the students, those who are listening, please understand, this is one of the unique type of webinars that I have also attended as a faculty. This, as I can understand, during the introduction itself, as the presenter said, that the gap between the industry and academia is very large. So because of which, when the students go to the industry as a fresher, they are totally alienated, and the industry also finds a great difficulty in absorbing as well as making these students understand the concepts of practical engineering and industry. So such courses are very much useful for the students. In fact, I feel that this was a very short and crisp presentation, where the first half, first 30 minutes or so, they introduced about their different courses and programs, and then they discussed about the distillation, sorry, about the pumps performance characteristics. Personally, I felt that the students response was relatively very poor. The students were not very active in answering simple questions which the presenter were mentioning. As I already said, I have a record. I will be taking the attendance from the presenters, and also I will be having a record of all the students who have responded to the answers. Students, again, my humble request that it was a very good session, not a pure theoretical textbook like, but what is actually done in the industry. So you are getting something that is being done in an industry before you are getting into an industry. So please understand its relevance. Try to ask maximum doubts. Answer all possible questions that you can. Okay, so that's it, Jatin sir. If the students are having any doubt, then let them ask. Else, then we can continue.
Thank you, William, sir. Yeah, we can go with the doubts and all.
Okay, so that was a very good feedback from the sir. So what my I want to convey is, the first thing is, suppose you are currently studying, right? So you should be eager to go to the other side of the uh, part, right? Currently you are in the domain of academics, right? Currently you are studying, so you should be prepared what I will be doing 2 years down the line. So अगर आपको पहले से पता होगा कि मुझे 2 साल के बाद क्या करना है, then that industry will be easily looking forward to take you in itself, right? So suppose if you are not ready with the basics, right, so at that time you might face some struggle. Generally, just giving you a very funny and a very simple example, right? So कोई भी लड़की की शादी होती है, right? So at that time what happens, उसको घर वाले सब बताते हैं कि when you go to the boy's house, जब आप ससुराल में जाओगे, you have to take care of these all things. So they are basically preparing themselves for the next part, whatever will be happening after 2 years later. So in similar way, you have to be get yourself prepared so that you can be easily absorbed by the industry. Because when I talk personally, so I find many people who are still struggling with 10, 12 years in industry, right, working in such a area, still they are not liking that industry. They are working in some conditions, some industries, like they are not happy with the life. So you select your domain. Currently you are in academics, right? So you can select कि मुझे ये particular company में जाना है, इस position पे जाना है, ये role में जाना है. So if you develop yourself, if you develop that kind of interest or that kind of curiosity, so on the other hand, industry will also be ready to absorb you. अगर आप when during the interview, if you honestly say कि मुझे सर इसका क्वेश्चन का आंसर नहीं पता है, बट मैं इसको सीख के मैं आपको आंसर बाद में बताऊंगा, या आई विल डेफिनेटली गो एंड लर्न दिस, और इफ यू आस्क सम क्वेश्चंस टू द इंटरव्यूअर आल्सो, राइट? सो व्हेन आई टेल माय एक्सपीरियंस, व्हेन आई sometimes go for the interview, students also ask some questions to me, back to me, sir मुझे ये समझ में ही नहीं आता है. So at that time we also explain. So if we find that type of interest from the students, लोगों को लगता है मेरा इंटरव्यू तो बहुत खराब गया, मुझे तो आया ही नहीं कुछ, राइट? सो अगर हमें स्टूडेंट्स में इंटरेस्ट दिखता है, सो दैट काइंड ऑफ स्टूडेंट्स आर गेटिंग एब्जॉर्ब्ड इनटू इंडस्ट्री, राइट? सो दैट you should be prepared with, correct? Okay.
Yes, sir.
Okay, so moving ahead with the pumps part. Just a minute, because of multiple files being opened. Uh, design related. So these all sheets are very complex, so it is taking a lot of time.
Hello everyone. Till then, please everyone fill the feedback form.
Okay. So that is related to the overall efficiency calculation of the pump, right? So moving ahead, we have different case studies. What are the system characteristic curves, right? So all these details, the system curve, friction and flow curve. So there are still huge amount of depth is there in this particular topic, right? So what I meant to give is how basically this sizing will be done, right? How we are providing the material, right? So that it can be useful for the students. They can also learn in a simpler way with the whatever topics are not covered in the academics, that basically we will be covering over here, right? So the main aim is to bridge the gap between the academics and industry, so that it will be easier for student to understand, right? So generally what happens whenever students are going to the industry, it takes at least 2 to 3 years to get settled, राइट? आपको 3 साल लगेंगे थोड़ा यूज टू होने में, कॉन्सेप्ट समझने में, राइट? सो इफ यू आर गोइंग थ्रू दिस कोर्स, you are understanding, right, even at in your college days. So what will happen once you join the industry, so whatever the 3 years you are taking, right, so that time will be shortened. आप 1 साल में सारे चीजें सीखने को स्टार्ट कर दोगे, राइट? So you will be easily able to understand, right, how it is basically operating, correct? So that is about the pumps, how this is a, some case study, that is effect of oversize of pump. बंदे ने गलती किया, कोई पंप को ओवरसाइज किया, so how that can affect.
Hello, sir. I guess your voice is not there. We can't hear you, I guess.
Hello.
Yes. Hello. Everyone is able to hear the voice of sir.
No, ma'am. We are not able to.
Yeah. Okay. I'll just talk to him.
Yeah,
Just a
please.
minute. Just to wait for 2 minutes, sir will rejoin. There is a issue regarding network. Okay. Everyone, please fill the feedback form. Have you filled that? Please respond.
हाँ
Yes,
भारती
ma'am.
Yes, ma'am.
Yeah.
Yes,
Okay.
ma'am.
Yes,
Yeah.
ma'am.
Yes, ma'am.
Yeah. Thank you.
Yes, ma'am.
So in the meantime, before the sir joins, by the time the faculty joins, I hope all the students are listening. So finally, students, as you all know, all these sessions that we are arranging, it is included in your overall performance index, which you all know what it is about and how important it is in your campus placements. So apart from attending these sort of webinars, the participation in these webinars is also very important. So whenever you are attending such webinars, it's very important as how well you are interacting with the faculties. If you're asking any doubts, do you answer the questions that they are asking? All these things is also very important. The training and placement coordinators are continuously monitoring these activities. So requesting all the students that when you're attending such sessions, please ensure that it's not just merely for attendance, it's also for understanding, learning something new. Okay, so please ensure your total participation, not just by logging in and showing your attendance. And as you all know, in Microsoft Team, the attendance they will give us like when a particular student have joined and when he exited. Okay, so for those students who think coming in once and immediately leaving will serve their purpose, it's not so. The fifth semester students also, please understand the importance of such sessions. After the sixth semester, you will have to undertake the summer internship, and then in the eighth semester again, industrial internship, final semester internship. So please get serious about your future because these sessions are not merely about teaching you any theoretical concepts or laws that you study in your book. These sessions are about getting you ready for the industry. These sessions are being conducted for you. So please take all these sessions seriously so that it is going to benefit the same way in which these sessions are being conducted. Because of some technical issues, the presenter is not able to continue. So he will be joining back very soon. So by
Yeah.
the time,
Okay. Till then. Yeah. Hello, sir. Yeah.
yeah,
Till
yes,
then,
ma'am.
I can complete my part of this webinar, right? Sir
Okay,
is
please.
having some problem with network. Till then, we can continue. Let me just share the screen. So, hello everyone. I'm Komal from Chem Club India. You are able to see the screen, right?
Yes, ma'am.
Yeah.
Yes, Komal.
So yes, this is great that you are showing the interest in this field because as a student in BTech, right? You have to be aware of all the faculty we are serving, right? Like in chemical industry, we have process department, operation department, safety department, all these things we have. So you should be clear about your future. You have to be decided now what you are going to do in future, right? So we are providing all the training programs related to process engineering. For that, we have process design engineering, which is basic and complete course because in degree you learn the theoretical part, right? All these theoretical things like material energy balance, all these things you learn, but how to apply that in real industry, real chemical industry, because you learn theoretically in degree, but you don't know the practical exposure of real industry. So you will be available, you will be able to assume or understand the real industry in this training, that is process design engineering, which is detailed course for a process engineer. What is the role of process engineer, what he should do in chemical industry, what are the concepts he should be aware of, that things you are going to learn. Then because chemical industry is digitalizing day by day, right? For that you have to be prepared. I mean, they use the softwares for designing and simulation like Aspen Plus, Aspen HYSYS are there, and also Unisim, Honeywell, all these things are there. So we have the complete license of Aspen, complete suite. So we provide the training programs related to Aspen, like Aspen Plus, Aspen HYSYS, Aspen EDR. Aspen EDR is a exchanger designer rating. How do we design the heat exchanger? And
Hello. Hello.
yeah, am I audible now?
No, ma'am, you are not audible.
You have not listening since 10 minutes or 5 minutes.
It's around 5 minutes or so, ma'am. You are not audible.
I'm really, really sorry. I guess I put it myself mute on mute. I'm really sorry for that.
Okay, ma'am.
Okay. Yeah, so we are providing all the training programs related to process engineering. Like we have process design engineering, which is detailed course for a process engineer. There you will get to learn about what is the role, I mean, what a process engineer needs to do in chemical industry. Because you are learning in BTech, I mean, you're learning in your college. That is all these things are theoretical. But what is the real industry must be, or how should you handle the real industry? That is included in the process design engineering course in detail. Okay. And because all these chemical industries are also digitalizing day by day, so you must have the skills regarding that. You must have know the softwares we use in the chemical industry for designing simulation. Okay. For that we have the Aspen Plus, Aspen HYSYS, Unisim is there, Honeywell is there. So we provide training programs related to Aspen complete course. We have Aspen Plus, Aspen HYSYS, Aspen EDR. Okay, what is the difference between Plus and HYSYS is, see, Plus we used for all the chemical industries for designing modeling simulation. In Plus, all the unit operation will be there, like distillation designing, heat exchanger designing, all the mixers, pumps, and all. Okay, in HYSYS, we also the purpose is different. That's why the software has differentiated. We use the HYSYS in refineries, mainly petroleum-based industries where there is a crude oil. We used Aspen HYSYS, sorry. We use Aspen HYSYS for all the petrochemical industries, and Plus for all the chemical industries. And there is Aspen EDR, that is exchanger design and rating. We use this Aspen EDR software for heat exchanger designing. What will be the shell type, all the things, or there are different types of heat exchanger, right? So for that we use Aspen EDR. Then we have distillation, which is very important. I mean, in chemical industry, you must be aware of all, everything about the distillation, because this is a very important thing in chemical industry. So its sizing and column sizing and rating will be done in Aspen Plus or HYSYS. And for advanced, we have PSV sizing, that is pressure sceptical sizing, which is most important part. I mean, highly pressurized equipments, we mount on the highly pressurized equipment, the PSV thing, right? Their sizing, how to do. All the hydraulics will be done by using FlareNet, Aspen FlareNet. Okay, so what are our features? So we provide all the live lectures, doubt clearing session, and if any of you is missed any of the live lecture according to your personal reason, then recorded will be provided to you. Recordings of all the sessions will be provided, and also we provide full-time assistance. If you need any of the help to if you are facing any of the problem regarding any of the course, then we will provide you assistance of tutors. We have also Aspen certification exam guide. What it is Aspen Tech company conducts an exam, which is a user certification exam. And if you are aware of all these trainings, like you have enough knowledge of Aspen Plus, Aspen HYSYS, then you can go for for this exam. That will be add extra curriculum to your skills. I mean, that will be beneficial to your resume, because I'm audible, right? Who removed me? Someone removed me, I guess, by mistake. Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, someone removed me, I guess, by mistake. It's okay, I'll share the screen. So we provide all the assistance regarding all the training programs, and you can ask any of the doubts to our tutor in any of the meantime. And also I was talking about Aspen certification user guidance. Actually, Aspen Tech organizes an exam where if you have enough knowledge of Aspen Plus HYSYS, then you can go for that exam. And once you pass that exam now, they will provide you user certification. That will be very beneficial to your future, to your career, because as a fresher you must have the skills, because degree doesn't that much matters. Degree matters, but you must have the skills. Then and then someone will absorb you in their company, right? You must have the aware of all the technical skills, like Aspen Plus, Aspen HYSYS. As a process engineer, you must have the skills. And also Aspen certification exam, we guide for that. So these are all the training programs we provide: Aspen Plus, Aspen HYSYS, Aspen ADR, Process Design Engineering. So course duration is this. Okay. And all the things, if you have any of the doubt till now, then you can ask me. Or otherwise, if sir has joined, we can go for, I mean, sir can continue. Yes, anyone of you have any of the doubt? Hello.
Ma'am,
Yes.
ma'am, can you change the meeting setting? Someone is removing continuously.
Who is removing? Just let me check. I guess one of you is someone doing something. Anything regarding the courses or training programs? Do you have any of the doubts? So we can go for that. Yes. Please be interactive. Make this session interactive, please. If you have any of the doubt, you can ask. Because as degree level now, you have this golden opportunity to learn all these things. Because after you graduate, you must acquire some skills, and you must spend your time in this all these training programs that you must learn in degree. Then why you are getting late? No? Many are wasting their time after the degree, and you have this opportunity to learn in this platform. Sir, did you join the meeting? Yeah, William sir. Am I audible now?
Yes, ma'am, I am already
Yes, ma'am.
there.
Yeah, because no one is asking anything. I mean, is there any issue or are you facing any of the problem?
Yes, ma'am. Actually, since the beginning of the session, I had informed Jatin sir once or twice that because of the settings, might be some students are removing other students, and
Okay,
as a result
okay,
of which, many students are getting removed. So they are again joining, rejoining. So if you can just change
okay.
the settings to
I'll
admin.
I'll just check. Yeah, I'll just stop presenting and I'll
Yeah,
ask sir to join and continue. I'll
yeah,
make all of this them. They are presenters now. Presenters can remove or add the students. I'll
yeah,
change their setting and let you know. Okay?
yeah. Please do it.
Yeah. Sir will join in 2 minutes. Just be patient. Okay? So actually, sir is having some issues he can't resolve. So let's continue for our. We can't show you the calculations regarding the Excel sheet in Pump. Okay. So let's start for process design engineering details, and we'll just have an intro. So process design engineering, I have already told you all that this is basic and what is a detailed course for a process engineer. So am I audible, right? For everyone, please
Yes, ma'am.
ensure me.
Yes, ma'am.
Yes. Yes. So what you need to do as a process engineer, and what are the things you should be aware of? So overview of industry you must have. So what is the role of process engineer in various fields? What are the basic requirements for a process engineer? You will get to learn from this course. Okay. Then what is the basic engineering packages and detailed engineering packages? What are the process basics? I mean process design engineer basics, like what is material energy balance you should be aware of. What are the different types of laws, unit conversions you need to aware. Then all the types of BFD, PFD. You must be able to read all the PNID, BFD, PFD, and also. what is BFD? That is block flow diagram. BFD is piping and flow diagram. All these three. Okay, process flow diagram, piping and instrumentation diagram. All the types of walls you have already learned, I guess, in BTech program. Like gate wall, ball wall. What are their purpose? We used for all these walls. What different types of purpose? We use different types of walls. So what you will get to learn in detail for that. And codes and standards, standards that like tema we use for heat exchanger designing. There are different types of codes and standards we must be aware of to design any of the equipment. Like we tema we use for a heat exchange designing. ASM is there for PSV sizing, I guess, and also distillation. And then what are the preparation of pipelining, how to do that, what is the line sizing, if there is a liquid stream or any of the compressible fluid, then what will be the pressure drop calculation for that. Okay, then hydraulics of a particular thing like line sizing by hand. Okay, then in control wall we are
Just a minute. Right. So basically for equipment designing, so where we include control valve, pumps, heat exchanger, distillation column, PSVs, storage vessel, pressure vessel, storage tanks. So wherever your calculations are being involved, in all those particular designing of the equipment, we will be having the Excel sheets, right? So that will be available to the students, and examples will be taken, and calculations will be done in the classroom session only, live session only, so that students can also understand how the calculations are done. Okay, you can carry on.
sir, you can go if you are able to join, I mean able to speak. Hello.
Yes. So
Yeah, please go.
yes, so you can just scroll down whenever I tell you. Okay. So basically, right from the preparation of the design basis, right, we have the heat and material balance. Then we will let you know how to prepare the BFD, that is a block flow diagram, process flow diagram, UFD. So this will be the part of basic engineering, right? Once the basic engineering is done, we will be focusing on the detail engineering. So what are the different types of valves? How the selection of valves has to be done, right? What are the different codes and standards that are used for the designing, right? So that we will see why it is required, right? What are the different statutory requirements, right? What is the Boilers Act, what is the Factories Act, right? And all the codes which are or the legal or statutory requirements which are must to know for a design engineer, that will be including, right? Then preparation of line list, line sizing, right? So for line sizing, what should be the diameter, what is the economical pipe diameter, what is the schedule number, right? So all those things we will be covering. Then control valves, so related to the control, how to size a control valve, right? Pump calculation, so that we saw. So what are the different types of pumps, what are the pump characteristic curves, what are the affinity laws, right? What are the different terminologies used for the pumps, how a pump should be sized, so design calculation for a pump, right? How the head and flow rate of a pump is fixed, right? And how to troubleshoot a pump. Okay. Next page. Yeah, other than that we have storage tanks, right? So design of a storage tank also, right? So next one is data sheets of different equipments, heat exchanger design, heat exchanger operations, right? Air moisture separators. So basically these are all air moisture separators, as well as we'll also cover this flash separators, right? Related to the pressure safety valve, then entire sizing of the pressure safety valve based on different scenarios. Then there is one fire case, there is blocked outlet case, over pressurization case. So different, for different cases there will be different designs, right? So that we will see. Similarly for instrument process data sheet, so there are basically flow transmitters, flow meters, level transmitters, pressure transmitters, temperature transmitters. So how to select different types of flow meters, right? So when it comes to suppose flow meters, then we have magnetic flow meter, right? Vortex flow meter, Coriolis mass flow meter. Then we have for pressure transmitter we have differential type of pressure transmitter, differential area pressure transmitter. Again we have orifice type, venturi type, right? So how to select between different type of instruments, right? which based on the accuracy, based on the requirement. So that we will see related to the cooling tower sizing, right? We will see what is how the cooling tower should be sized based on the range, based on the approach, based on the WBT, right? Dry bulb and wet bulb temperature. What are the tons of refrigeration? How the efficiency of the cooling tower is calculated, right? Steam ejectors, flame arresters, static mixtures. So these are all special kind of equipment. So this will be covered in SMDS, right? So SMDS is special material data sheet, right? These superheaters, mass and energy balance equations, right? So what is the latent heat, what is the specific heat, how it has to be used, how the calculation has to be done for utility requirements, right? So different utilities, how to prepare the list of utilities and capacity of the utilities, right? What is hazardous area classification, right? And finally we'll see what are the different softwares that are available in industry and how to use that software, so that most of our calculations, right? So whatever manual calculations which we are doing, that is already formulated, already documented, and with the number of iterations that is running behind the software. There are different logic diagrams, there are different you can say what we say, uh, some models are being running in the background of the software. So once you know what the manual calculations are, what the concepts are, you can switch to the software part. So once you are through with the basics, you can also start learning the software. So these all things will be included in the PDC course, right? So basically the software part is for the professionals, right? So who have spent at least 2 to 4 years at least in the industry, so they will be easily able to grasp the software part. So mostly for the freshers or for the 1 to 2 years experience people, this particular course PDC will be very helpful, so that they can come to know about the design standards, design different ways of design, how it is done in the industry, right? So that's it from my end. So I will request Komal, right? You can give the any query they have, students have related to the course. You can answer them and give them the mail ID and the contact, so that any student want to join, they can contact us. Okay, so thank you. That's it from my end.
Yes, thank you, sir. And I would like to add in that, because at the end of the process design engineering course, we provide the guidance for interview for process engineer. We provide the guidance, so it will help you. It will be beneficial to you all of the freshers over there. So regarding the any of the training programs or any of the course, you can ask any of the queries you have. You can go for it. Please, go for it. Yes, yes. Any one of you? I'm audible, right, for you all?
Yes, ma'am.
Yes, ma'am.
You are audible.
Yes. So do you have any of the doubt regarding training programs or regarding your syllabus or anything? Okay. Then should I conclude the session? Yes, William, sir.
Yes, ma'am, we can conclude.
Yeah, okay, we can conclude the session. So before that, did you everyone has filled the feedback form? So it will be easier to us to send your certificates and all.
Yes, ma'am.
Yeah, great. Thank you so much, everyone. And I hope there was some issues, technical issues. So apart from that, the session was helpful for you, I guess. And for I guess this is very this will be useful for your future also. So thank you from the team Chem Club India. I welcome you always on the behalf of team Chem Club India. And if you don't have any of the doubts, so we can conclude the session. Thank you, everyone. Thank you, William, sir, for this opportunity you have given to us and also the students who have participated in this webinar. Thank you, everyone. Thank you.
Ma'am, I have a question.
Yeah, please go for it.
मैम मैंने सुना था कि केमिकल मतलब कोई भी प्लांट में केमिकल इंजीनियर बहुत सारे होते हैं, एक प्रोसेस में होता है, एक डैशबोर्ड में होता है, एक लैब में होता है, और एक जगह थी वहां पे होता है। मतलब मैम इसके बारे में आप डिटेल में बता सकते हो? और
मतलब डिपार्टमेंट्स के बारे में बोल रहे हैं आप?
हाँ, कि मेनली क्या होता है
केमिकल
डैशबोर्ड में, केमिकल इंजीनियर का रोल क्या होता है, प्रोसेस में क्या होता है, लैब में और क्यूसी में क्या होता है?
क्यूसी मतलब क्वालिटी कंट्रोल, राइट?
Yes. So
हाँ
just let me answer this. So
हाँ
basically, whenever chemical engineer, there are multiple departments, right? So first of all, one is the production, right? So where you will be entering, looking after the production. So you have to handle the people at the shop floor, right? Whatever breakdowns are there, कहीं पे कुछ चोक हो गया, कहीं पे कुछ लीकेज हो गया, so you have to handle those scenarios, handle those emergencies as a shift engineer or as a production engineer, right? So in that particular role, you will be working in shifts, you will be taking out the productions, and you will be working with the permit systems. So जहाँ पे आपको कुछ भी काम करना है, उसका permits बनाना है, so all the documentation part will be coming in the production role, right? Next one is the design phase. So where your process engineering will come into picture, जहाँ पे आपको डिजाइन करके उसको एक बार चला के नेक्स्ट प्लांट, नेक्स्ट प्रोडक्ट को डिजाइन करना है, उसको चलाना है, देन अगेन हैंड ओवर. सो व्हेन इट कम्स टू प्रोडक्शन, तो उसमें एक ही प्लांट में यू माइट नीड टू वर्क फॉर मल्टीपल ईयर्स. बट जब प्रोजेक्ट्स है, तो whenever you commission, whenever you design one product, hand over to the production team, उनको चला के एक बार सिखा के आप समझा दो, they will keep on running. When it comes to QC, so basically QC में chemical engineers का ऐसा there is very little role, right? तो हमें उनको सिर्फ स्पेसिफिकेशंस देने हैं कि आप कोई भी प्रोडक्ट का एनालिसिस करो, तो दिस शुड बी द स्पेसिफिकेशन, उसका कंपोजिशन ये होना चाहिए. सो वंस वी हैंड ओवर दैट, other than this we have no roles in QC. So quality check, quality control and quality analysis, QA and QC, these both departments are solely and totally handled by the chemist, right? So these are all MSc and PhD and BSc people. So these are all science stream people. So engineering point of view, we have no role in QC. Definitely we have some role in pilot plants, right? Suppose we want to develop a product, so directly we cannot go to commercial level, so we have to do some piloting in the pilot plants जहाँ पे छोटे छोटे reactors है, छोटे distillation columns है, right? So once we do that trials in pilot plant, so we can have some interpretation, हमको कुछ ideas मिलेंगे कि pilot plant में जो problems आई, right? pilot plant में कुछ issues आए, so that issues we will highlight, and we will uh, design in such a way that these kind of issues will not happen in the commercial plant, right? So that is where our role will come. So as a process engineer, our role will be in pilot plant, our role will be in basic engineering, then detail engineering and projects. As a production engineer, you have to handle the shifts and the permit system. So these are the domains where a role of a chemical engineer will come into picture. Clear?
Thank you, sir.
Yes, anyone is there who have still doubts? Yes, you can go for it
No, ma'am.
if you have. Okay. Then, okay, everyone, thank you for everything, and thank you for joining and making this webinar so interactive. Thank you. And here I would like to conclude the session. Thank you.
Thank you, ma'am.